Unit 8, Subsection 1, Antiderivatives, Part 4, Taking the Integral of Multiple Functions, Reverse Chain Rule. Okay, so in this section, we're going to talk about how to deal with the chain rule. Like, we've dealt with it a little bit with the cosines and the sines and the e to the x's, and those were pretty basic. And what happens when the chain rule is a lot more complicated? So that's kind of where we're going. And in order to do that, I need you to recall the u function from the chain rule. So that was Unit 2, Subsection 2, Part 4. So if you need to review that, go ahead, but watch this first and then see. The u function is the part that we apply the chain rule to. I know that we never really went further than that because it tended to just get in the way and we'd made our calculations longer, so whatever. But it's there, so you can review that section. It will be that way here too, but until we get good at recognizing the u function, using it is a really good idea. So here's what I want you guys to do for this one. Identify the u function and then find the derivative of this. Okay, so the u function is the part the chain rule applies to, so the part that's inside the brackets. So here, u is x cubed plus 5. So really, this works out to f, and technically it's going to be u, equals 3u to the 4th. Okay? So then, to get f prime of the u function, we ended up with 4 times 3, so that's 12u cubed. Okay? And then we had to go du. Okay? Not a problem, because we usually don't do that part, but, well, we can. So anyways, then we figured out, so du here is 3x squared. Okay, awesome. So really, this now worked out to f prime of u equals 12 times the u, put the u function back in, so x cubed plus 5, okay, cubed, and then the du was times 3x squared. Okay, great. And then, of course, the 12 and the 3x squared go together, so you end up with 36x squared x cubed plus 5 cubed. Okay, so that was our final function. Technically, I guess that'd be dx. Okay, great. All right. So there's the using the u function for the chain rule. Awesome. Okay, now here's the thing. The original function is this, 3x cubed plus 5 to the 4th. The derivative is this, x cubed plus 5 cubed. Please note that the u function is also contained in f prime. In fact, the u function will always be present in the derivative if you use the chain rule. Okay? If we can identify the u function, then we can use it to find f of x from f prime of x. Okay, so all sorts of fun. Find the indefinite integrals of the following. So, if we look at this, I'm going to show you how to use the u function because I believe that it is easier whenever we have the chain rule that's fairly big like this. So we're just going to say that the u function is 3x plus 4. Okay, now let's figure out the derivative. So the du dx is going to be just 3. Right? The derivative of that is 3. Now, we got to do one little extra step here. Okay? We're always going to switch those two. And you'll see why here in a minute. So then dx equals du divided by 3. Okay? That's what gets rid of the chain rule for us. So then watch how this integral becomes, or what this integral becomes. So the u function was just the 3x plus 4, so that's now u to the 5th. Okay, now the dx is this part. Well, that's du over 3. Oh, okay. So really, this is now the derivative of 1/3 u to the 5th du. So what that means is 1/3 u to the 5th, the derivative with respect to u. Okay? Or the variable u. All right, so let's integral that. Okay, so that is, so raise the exponent by 1. So u to the 6th, multiply by the reciprocal. So 1/6. Okay, plus c. The du goes away. Okay, so 1/3 times 1/6 is 1/18 u to the 6th plus c. And then we put the u function back in. So 1/18, the u function was 3x plus 4 to the 6th plus c. And that is our final answer. Now, let's check to make sure that it actually worked. So if I take the derivative of this, I should get 3x plus 4 to the 5. Should. Okay, so the 6 comes down, so you get 1/18 times 6, 3x plus 4 to the 5, and then we have to chain rule out a 3. Okay, well, 1/18 times 6 is 1/3, and 1/3 times 3 is 1. So basically, you can look at it, 6 times 3 is 18, 18 times 1/18, so those all cancel, and you're left with 3x plus 4 to the 5th. Oh, look, 3x plus 4 to the 5th. That's exactly what we started with, so we're right. Using the u function basically divides out the chain rule without us having to think of what it had to be. It's just an easier way of doing it. Please use this, and we'll go from there. So if we look at number 2 here, okay, so first things first, we're going to rewrite this. So 2x plus 3, and that would be the square root, so that's 5/2 dx. Okay, so it's quite clear to see that the u function is 2x plus 3. Okay, remember, the u function is always what's inside the brackets. So then the derivative of u, du dx, is 2. Okay, awesome. Now, great, so we do the little switch thing here. So dx equals du over 2. So then we just make that nice little substitution, 5u to the 5/2 du over 2. Okay, so this is the part that we want to integral or integrate. Okay, before we even do that though, we put this thing with the other number. So this is 5/2 u to the 5/2 du. We always combine that, and then we just follow our rules. So we take the integral, so raise the exponent by 1. So that's going to be 7/2 times 2 over 7. All right, raise the exponent by 1, multiply by the reciprocal, add c. Okay, so let's see, 5/2 and 2/7, so the 2's are going to cancel. So that leaves us with 5/7 u. Well, now we can substitute the u function back out. So the u function was 2x plus 3 to the 7/2 plus c. So there is our integral. Okay, let's just make sure that works. Okay, so the 7/2 comes down in front. So we get 7 halves times 5 sevenths. Okay, 2x plus 3 to the 5 halves, and we chain rule out a 2. Okay, so the 7's cancel. The 2 and the over 2 cancels. So then you end up with 5x squared plus 3 to the 5 halves. So 2x plus 3 to the 5 halves. That's the square root part. So we are right. Wow, I know that's intense, but we'll practice a few more times. Okay. So here, the u function is this part inside the brackets. So u equals 3x squared minus 6. So then du dx. Okay, so the derivative of that. Okay, so the 2 comes down, so that's now 6x. That's great. Okay, and then we switch those two. So the dx equals du over 6x. So watch what happens this time. So now I end up with the integral of 5x, 3x squared minus, that's funny. So 5x, and then u cubed, and then dx we have said is du over 6x. Okay, well now this 6x is on the bottom and it combines with that 5x, so this is the integral. Well, look, the x's are going to cancel. The x's cancel, so you're going to get 5/6 u cubed du. Okay, now we just take the integral of that. And that gets, what that does for us, it gets rid of the chain rule part. Okay, so 5/6 u to the 4th. So raise the exponent by 1, multiply by the reciprocal. Okay, add a constant. Okay, so that's going to be 5 over 24. Right, 5 times 1 is 5, 6 times 4 is 24. U to the 4th. Well, we can substitute the u function back in, so 3x squared minus 6 to the 4th plus c. So there's our integral. Now let's just make sure that it actually got rid of the chain rule like we wanted it to. So if we take the derivative, the 4 comes down, so we're going to get 5/24 times 4, 3x squared minus 6 cubed. Okay, and then we chain rule out. Okay, 3 times, so that's going to be a 6x. Okay, so when we do that, we get the 4 times 6 is 24, so that's going to cancel off the bottom. So you're going to get a 5, there's still an x, 3x squared minus 6 to the 3. And oh, look, it worked out. It's the answer. Oh, and then the dx comes from, we're taking the derivative with respect to x. So it works. Doing it this way gets rid of the chain rule. Awesome. Okay, let's look at number 4. Again, the u function is just under the square root part there in the brackets, so 1 minus x cubed. How we know that this is a u kind of scenario is if we take the 3x squared, if we take the derivative of that part, 3x squared, look, there's an x squared up here. If you were looking at this as if you were deriving this instead of integrating, this would be a product rule or a chain or a quotient rule, pardon me. And we want to make sure that we don't integrate like that. We can do something later on called integration by parts, but that's for your university and college professor to teach you. Right now, we want to make sure that this extra x squared is going to cancel off using this u function trick. So anyways, so the u is 1 minus x cubed, so then du, the derivative of u with respect to x, Okay, so that's going to be negative 3x squared. See, the x squareds will cancel off from up top there, just where we're going. Okay, so we always switch those. So du over negative 3x squared equals dx. Okay, so then this becomes the derivative of integral of x squared u to the 1/2 on the bottom there, right? Actually, we should spin that up, right? Because he's a square root on the bottom, I should just write him as x squared u, so x squared u to the negative 1/2, right? Negative square root on the bottom is a negative 1/2, okay? And then dx equals du over negative 3x squared. So look what happens. The x squareds cancel. So this is now, that's the chain rule part. So this is now, that's a 1. So 1 over negative 3. Usually the negative goes up top. We'll change that later. Negative 1/2 du. So now we've gotten rid of the chain rule. So now we just take the ordinary integral. Okay, so we'll move that negative up. So negative 1/3 u. Okay, so then negative 1/2 plus 1 is positive 1/2. Okay, and plus c. Whoops, missed a step. Okay, so raise the exponent by 1, multiply by the reciprocal. So the reciprocal of 1 over 2 is 2 over 1, then plus c. There we go. Okay, so then the 2 over 1 multiplies by the negative 1/3, so that's going to be negative 2/3. Okay, we can put the u function back in, 1 minus x cubed, okay, to the 1/2 plus c. So there is our final answer. Now, I'm just going to use the space for number 5 really quick. Let's check. Okay, so the 1/2 would come down in front. So 1/2 times negative 2/3. Okay, and we get 1 minus x cubed to the negative 1/2. Okay, and then we chain rule out a negative 3x squared. Okay, so let's see. The 2's cancel. The negatives cancel. Negative and negative make a positive. The plus 3 cancels off with that 3. Okay, so you have a 1 left on top, so a 1x squared. And then 1 minus x cubed to the negative 1/2, which of course is a square root on the bottom. So square root of 1 minus x cubed. And if you have a look, that is our original question. So we're right. Woohoo! Thank goodness for the u function. Okay, so I'm going to erase this little piece here because I need the space for number 5. Okay. Number 5, ln x over x. Okay. Now, which one is the u function? Remember, the u function is the chain rule of the original. So the u function here, okay, if it's the chain rule, then what we end up with is, okay, so the derivative of ln x equals 1 over x. So our u function is going to be the top part because the chain rule was the 1 over x. So really this separates out into kind of like this, ln x times 1 over x. That's the same as ln x over x. Okay, and the derivative of ln x is 1 over x. Okay, so our u function is the ln x. So u equals ln x. Okay, the derivative of that, the du dx equals 1 over x. Okay, awesome. So then if the dx comes up, then the x can go like this. So x du equals dx. Kind of a tricky one. It's different. Okay, so then we end up with the integral. Okay, so ln x was u over x, and then the dx is x du. Oh, look what happens. The x's cancel, and I get u du. Okay, so now we just take the integral. Okay, so raise the exponent by 1, multiply by the reciprocal, add a constant. Okay, so this is 1/2. Then the u comes back, so then ln x squared plus c. And there is our answer. Let's just make sure that works. So the 2 comes down, so if we take the derivative of this, so 2 times 1/2 is just 1. So then you get ln x, okay, and then you have to chain rule the ln x to get 1 over x. So this is ln x over x, which is exactly what we were supposed to get, so we are right. Yay! Okay, let's try this with some trig. Now, finding the u function is a little bit tricky. It's not crazy, but it's not too hard either. So what we're trying to do to get the u function is we're trying to figure out which one's derivative is the other guy. So remember, the derivative of sine is cos, and the integral of cos is sine. So that's good enough, because really, if I take the derivative of sine, I get cos. So this part here, the cos, that's the chain rule. That's the chain rule part. Okay, so really we're going to make u equal sine x, and then du dx, the derivative of u with respect to x, is derivative of sine is cos x. Okay, so then we switch those. So du over cos x equals dx. So now look what we get. So we want to take the integral, and the sine is the u, so we get u cos x. So u cos x, and then this would be, as soon as I take the integral sign, we put the dx in there. So then dx would be du over cos x. Oh, look, the cos x's cancel, and you get the integral of u du. Oh, okay, so raise the exponent by 1. So u squared times by the reciprocal, add a constant. So this is going to be 1/2. The u function was sine x squared plus c. Okay, and then we can, so that's mostly our answer. Okay, so then the 2 comes down, so 2 times 1/2 is 1. Okay, so that would be 1 sine x, and then we chain rule the sine x to get the cos x. Okay, derivative of c is just 0, so it disappears. Oh, look, we get sine x cos x, which is exactly what we were supposed to get. So that is our answer. Now, one little tweak here is we usually write a sine squared in there, though. So that is the answer we want to write down. So 1/2 sine squared x plus c. Okay, we're almost there, everybody. Okay, so a few more. So this guy here, obviously this part is the u function. It's got the brackets and everything. Okay, so u equals 2 plus sine x. So then du dx, the derivative of u with respect to x. Okay, the derivative of 2 is nothing, so sine x is just cos x. So that means that dx equals du over cos x. Okay, so this now becomes the integral of u to the 10th cos x Okay, and then times du, so that's the substitution of dx out. So dx equals du over cos x. Oh, look, the cosines cancel. That's the whole point of the u function. Okay, so then we're left with the integral of u to the 10th du. Awesome. So then we raise the exponent by 1. So u to the 11th times the reciprocal, 1 over 11th, plus c. Okay, so then we put the u function back in. So the u function was 2 plus sine x to the 11th plus c. Awesome. Hopefully you're starting to get the hang of it. Okay, now number 8. So this, we have the e functions. Now, we've done e functions before. We just kind of used the chain rule just implicitly to figure out what we had to do. This time we can actually use it as a u function. So remember, the u function isn't going to be e to the x, because e to the x is just e to the x. So the u is always going to be the exponent on the e, because that's the part we chain rule. So u equals negative 2x squared. It's always the exponent on the e. Okay, so then du dx, okay, that's negative 4x. So then dx, switch those two, is du over negative 4x. So watch what happens now. So we get the integral of 3x e to the u, and then du over negative 4x. Oh, look, the x's cancel. Nice. So then really all we're left with is negative 3 over 4 e to the u du. Okay, so we take that, so negative 3/4. Okay, the derivative, or the integral of e to the u is just e to the u plus c. Okay, great. So now we put the u function back in, so negative 3/4 e to the negative 2x squared plus c. So there's our answer. Now, let's just check to make sure it's right. Okay, so the derivative of e to the x is just e to the x, so that's negative 3/4 e to the negative 2x squared. But then you have to chain rule out. Okay, so chain rule the negative 2x squared, so then get negative 4x. Okay, the two negatives cancel, the 4's cancel. So then the x goes with the 3, so 3x e to the negative 2x squared. And oh, that's exactly what we started with, so we are good to go. Yay! All right, 2 more, and then I'll stop talking. Okay, so we have sine cubed and then cos. So the one with the exponent is always the u function. So u equals sine 3x. Okay, great. So then du dx. So the derivative of sine is cosine. So that is cosine 3x times, and then we've got to chain rule out the 3x, right? So chain rule out a 3. So du dx equals 3 cos 3x. Awesome. So then dx equals du over 3 cos 3x. Okay. So putting that in, whoa. Okay. So that is the integral of u cubed cos 3x, and then the dx is du over 3 cos 3x. Oh, well, the cos 3x's cancel. So really this is 1/3 u cubed du. Okay, so see how using the u function just makes the derivative part so much easier. Okay, so raise the exponent by 1, multiply by the reciprocal, add a constant. Okay, so this is now 1/12, and the u function was sine 3x. to the fourth plus c. So of course we rewrite this as 1/12 sine to the fourth 3x. Okay, plus c. That's the idea. And you can check this one if you want, but you can do that by yourself. Trust me, that is our guy. Okay, and then the last one for this section. Hooray, I know it was a little bit of a long one, but that's all right. Okay, for this guy, the u function is going to be the bottom part. Well, it has to have an x on it, so it can't be the 6. So the u function is going to be 3x minus 1. So the du dx is going to be 3. Okay, which means that dx equals du over 3. So watch what this becomes. So the integral of 6 over u, and then dx was du over 3. Okay, so the 3 and the 6 reduce. So that is the integral of 2 over u du. Okay, so there's a single u on the bottom, right? So if we raise the exponent by 1, we get u to the 0. So that's what trips you off to saying this is a ln. Okay, so this equals, okay, so the ln, whoops, pardon me. So we'll leave that 2 there. So 2 ln, remember, this is absolute u, is how these work. Okay, plus c. Okay, awesome. That's it. Now, we can check our work, though. Okay, so the derivative of ln u is just 1. Ooh, that's not it. That's very funny. Because, of course, we have to put the u function back in. So 2 ln 3x minus 1. Now, technically, that's absolute valued plus c. There, now we're done. Awesome. So then when we try this now, so if we take the derivative of this guy, so we end up with derivative of ln 3x minus 1 is just 1 over 3x minus 1. So 2 over 3x minus 1. 3x minus 1, and that chain rolls out a 3. So this worked out to 6 over 3x minus 1, and then I guess it is the derivative with respect to x, so we can put the dx there. So, oh look, that is our exact question, so we know we did it right. Okay, so that's it for this part. Please complete the formative and summative assessments for these. I know they're a little tricky. Watch the video again or give me a shout. Whatever you guys need. We'll make it work. Thanks.